Okay, we're going to continue talking about projectile motion. This time, we're going to fire the ball at an angle, and it's going to change the problem slightly. So we have a cannonball that's being fired from a cannon with an initial velocity of 40 meters per second, an angle of 30 degrees. And what's going to happen is as soon as it's fired, gravity's going to start pulling down on it. That arc, and end up hitting the ground over here. Now, again, I have to split my variables into x and y. I know the accelerations. For x, the acceleration is 0. For y, the acceleration is gravity. Okay? Now, I look at this initial velocity, and I say, is that an x thing or is that a y thing? Well, it's a little of both, right? It's going sideways and it's going up. So what I have to do is I have to split that initial velocity of 40 into its x component, its y, and the angles down here. So when I look at this, the x is the adjacent side, and y is the opposite side of the triangle. So I'm going to use cosine for x and sine for y. So for b0 of x, it's going to be 40 cosine 30. And that's going to give me a value of 34.6. And for b0y, it's going to be 40 times the sine of 30. And that's going to be 20. So now I'm going to use those. So in the x direction, b0 is 34.6. In the y direction, b0 is 20. Now I need a third, and again, just like when I was throwing the ball straight upward, the highest point is going to be important. Because at that moment, it doesn't come completely to rest. It's still moving sideways, but it's moving straight sideways. So I know that its y velocity there is 0. So I make a note that the velocity is 0 at the top. Now again, I'm going to use the y side. I'm probably going to solve for time first, and I'm going to use this equation this time. So then 0 equals 20 plus minus 10 times t. If I solve that, I'll end up with t equals 2 seconds. So I'm going to make a note that that means to top. So t equals 2 to the top. Now, I might want to find, say, how high it's going to go. So I'm looking in that case for delta x. So I can say delta x is b0t plus 1 half bt squared. Delta x equals 20 times 2 plus 1 half times minus 10 times 2 squared. So this is 40 minus, and this over here is going to be 20. So I know delta x is 20 meters. So we'll say delta x is 20 meters to the height. Okay, now I also want to find out how far it went horizontally. Okay, now you'd say the time is the same for x and y, but if it's 2 seconds to the top line, it's going to be double that for the whole trip. So it's time over here, we're going to make 4 seconds, and then use that to find delta x. Again, the acceleration is 0, so I can ignore that term. And I will just get delta x equals to 34.6 times 4. And end up with a distance of 138.4 meters.